Now we're going to move on to talking about the area of a circle. Now, if you've noticed a trend here, it is that circles are complicated. They gave the ancient Greeks a lot of trouble in terms of calculating them. And if you remember from circumference videos and estimations of pi, the curved edges of these circles are very problematic. They pose a lot of issues for us, and it even led the Greeks to invoke, I should say, the principle of infinity. Of kind of, if you look at the polygons from a few videos ago, we were saying, well, a polygon with infinitely many sides, it's going to produce a circle. And the more sides our polygon has, the closer of an estimate we can get for a circle. Now, a similar thing happens when we deal with area. Now, we have curved surfaces here. So these mess us up. We can't just deal with this in the same way as we would for quadrilaterals or triangles or any of these nicely behaving shapes. A circle, it's a little bit trickier to deal with. So once again, I'm going to give you in this video, hopefully a slow deep dive into how we can come up with a formula for this instead of just giving it to you right away. And I'll hopefully be talking about a lot of the similar principles that Archimedes looked at in his creation of this, in his derivation of this formula. Now, what do we know about circles? Well, we know it has a radius from here to here, and we know that its circumference, so the total border around the circle, we know that the circumference is equal to 2 pi r, or pi times the diameter. But here I'm explicitly using the formula in this form because the diameter is just 2 lots of the radius. So we can express the circumference as 2 pi r as well. Now, we're still at a bit of a standstill, right? So we don't really know what to do here. We want to find the area here. So what Archimedes did is, let me actually get another circle up here. Whoops, that's not what we want. Here we go. What Archimedes did is he said, all right, well, I don't really know how to find this entire area. So what I'm going to do is I'm just going to maybe chop this up into slices in the same way we would cut a pizza, for example. So I'm going to cut this into 8 equal slices. I know I've drawn that pretty badly, but just imagine these are equal. And I'm going to unravel this, so to speak. So if I take, for example, this point here and sort of cut this here, and if I were to roll this whole thing out, and I would essentially get, let me actually draw the in-between step. I would get something that looks like this. I'd have 1, 2, 3, 4, 5, 6, 7, 8. I would have 8 little pizza slices here. Please forgive my bad drawing. I'm hoping it'll get better with time. But unraveling all this, I get all my pizza slices in a nice little row here. Now, this doesn't really help us yet, but we can make a link here. Well, we can say that each of these sum up to our circumference. I hope you can see that there. But we can say the difference between here to here is 2 pi r. And each of these little slices, these little straight bits here, well, they are just our radius here. Here, 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 here. And we can see that there. For example, these two here correspond to these two here. So we can say that all of these are a length r. Now, still not really where we want it to be. And I gave you a little hint earlier that we're going to talk about this principle of infinity again here. So what I'm going to do, I'm going to take these four and I'm going to fold them onto here. And let's see what we end up with. Well, I should get something like this I'm going to try to draw this really nicely as I can. I'm going to get these happening here. And folding these over, these are just going to fill in my gaps here. And I'm going to have another one here. So nothing's really changed other than the orientation here. But I still have my 8 slices. 1, 2, 3, 4, 5, 6, 7, 8, which correspond to these here. Now, what have I created? Well, I have that my radius is still the same. So from here to here, I have a radius of r. But this length here and this length here make up 2 pi r. So we can say that, well, each of these just make up half of my circumference. So I can say that this is pi r. This is the length of pi r. So 1, 2, 3, 4. All of these make up a length of pi r, as well as these make up a length of pi r. Altogether, we get 2 pi r. Now, what shape is this starting to look like? Well, some of you may notice that I've got this here. These kind of look parallel. I sort of have these things happening here. We can roughly see that we are slowly making this look like a quadrilateral. Now, what would happen if we had more little pizza slices? So these were smaller and smaller and smaller. And say we got an infinitely large amount of pizza slices. Well, this whole thing is going to get condensed. And I'm going to switch slides now to a simulation on GeoGebra where you can hopefully see what's happening here. So most of the stuff I've already done in the video, but I'll just run through it again here so you can see. But we have our circumference here of 2 pi r. Now I'm going to dissect this. And here it's dissected into 12 parts. And I'm going to fold this over in the exact same way I did in the video. And I end up with something like this, very similar to what I had. Now let's bring forward this idea of infinity. Let's slice these, let's make this pizza into infinitely many slices. I probably won't get infinitely here, but imagine a lot of slices. And if you see here, well, this is becoming a lot more rectangular. I've sliced this into 200 parts. And the more little parts we have, the closer this begins to look like a rectangle, like a quadrilateral. So we're going to look at the dimensions. We still have our r, and we have our length here as pi times r. So let me redraw this here. So say I've sliced this into kind of infinitely many slices so that I eventually end up with a rectangle of dimensions r and pi r. Now, by talking about this idea of infinity, we have essentially straightened out these curves. We've gone from here to here. We have, by slicing this up into little pizza slices, we get to, this is a construct more than anything, but we have hypothetically constructed a rectangle by cutting this into small bits. So as the pizza slices tend to infinity, the shape of this tends to the shape of a rectangle. So we know how to deal with rectangular areas. We just multiply this dimension by this dimension. So therefore, the area of our circle equals r times pi r. Now, we have like terms here, so we can simplify this and write it as pi r squared. And that is the area of our circle. We've gotten rid of the problematic curved edges. And by talking about this idea and using, I should say, this idea of infinity, we have constructed a shape that we are familiar with, which allows us to derive our equation for area. I'll see you guys next time.